So this week in class we discussed prime factorization, which is basically rewriting a number as the product of its prime factors. For those that don't remember, a prime factor is a factor of a larger number that what makes it prime is the fact that it can only be divisible by 1 and itself. So 3 is a prime number because its only factors are 3 and 1. So what we're going to do is we're going to take the number 3300 and change it to all its prime factors. So I always start with looking at whether it's divisible by 2 or not. And because this is an even number, it is divisible by 2. And that green is really hard to see, so we're going to switch to black. So we've got 3300. And we're going to divide it by 2. And that gives us 1650. Again, is it prime? Is it even? Yes, it is. So we can divide this by 2. 1650 divided by 2 is going to be 825. Now I check that. Is that divisible by 2? No, it's not even. So I go to the next prime number in the list. The next one would be 3. Is it divisible by 3? Yes, it is. And how do I know? Because I do the 8 plus 2 plus 5 adds to 15. And because 15 is divisible by 3, then this whole number is divisible by 3. So 825 divided by 3 will equal 2, 7, 5. 550. Yep, that works. Now I'm going to try that again. 2, 7, 14. That does not add up to a number that's divisible by 3. So 3 is not going to work. We already know 2 won't work. So our next prime number after 2 and 3 is 5. And because this ends in 5, we know it's divisible by 5. Divided by 5 equals 555. That again, divisible by 5. Equals 11. And 11 divided by itself, because 11 is a prime number, and that leaves me with 1. Once I am down to 1, I have all my prime factors. So where are my prime factors? All of these numbers in red are my prime factors. So now I can say 3300 is equal to 2 times 2 times 3 times 5 times 5 times 11, which also can be written as 2 to the power 2 times 3 times 5 squared times 11. So 3300 listed, written as all its prime factors, would be this.